so this is the last one of the 28 problems, and this is a voltaic cell. Now I know this comes later on in the sections. I forget exactly where it comes in the section. So this would be an excellent introduction. So this question, this one, 24, is one that I would ask that you watch this first and see how I'm doing it. You get a better idea as to how voltaic cells work or galvanic cells work, because you know this is like I'm going to show you what's going on here. So let's take a look at this. Voltaic cell, similar to the show that shown in figure 20.5, is constructed. One electrode compartment consists of aluminum strip placed in the solution, and the overall reaction is blah 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 blah. And nickel, oh, that's nickel sulfate. So what's being oxidized and what's being reduced? Okay, so this is a very simple redox equation because there's no oxygen involved. There's no, we don't have to do balancing with water or balance anything actually because it's already balanced for us. So let's see what we got here. So I'm going to go through this a little quickly because this covers all of the stuff that we've already talked about. So one of the half reactions is aluminum here going from 0 to aluminum's going to a +3. And that means that we are moving right on the line from 0 to a +3 on my number line, which means that this is oxidation. Okay? The other one then, of course, is nickel going from a +2, and then that's going to a 0. Not a 0, just to 0. And that means that it's going in the opposite direction. I got here from the +2, and then it goes to 0, which means that this is reduction. Okay, so green oxidation, red reduction. So it says what's being oxidized and what's being reduced. So aluminum is being oxidized, obviously, and nickel is being reduced. Okay, you see how I figured that out, right? The half reactions that occur in the two electrodes, I actually did that already. So we can do, I don't mind rewriting that, that's fine. So for oxidation here, write the half reactions that occur at the two electrode compartments. If it's oxidation like this, that means that this is happening at the anode. Oxidation and anode both start with vowels. That's how I remember it. So that means that the other one is reduction. Ooh, please, +2, there we go. And this happens at the cathode then. Okay, so far we're going pretty easily like this. And this is one of those things that lots of people get confused. They can't figure out. So oxidation at the anode, reduction at the cathode. Please remember that. Write that down. I think there's actually a mnemonic device for that. I forget what it is. I'll talk more about that and try and remember it for the next podcast or whatever this is, screencast. So voltaic cell, this is the same thing. So the next question for letter C is what electrode is the anode? Which electrode is the anode and which is the cathode? Okay, maybe I'm missing something here. That doesn't seem to make a whole lot of sense to me. So, it's asking for which metal. So the electrode, the anode then would be the aluminum metal. Okay, sorry about that. I got confused. I'm not sure what the problem was. That's weird, strangely, and I think I screwed that up from typing it out from the book. So that means that the cathode then would of course be the nickel. Okay, I'm not sure why that's a separate question, but okay. Indicate the signs of the electrodes. Now, the signs mean, like, obviously the aluminum part at the anode, what sign is that? Now here's the part that I like about this, is that you can actually trust, guys, you know that if I'm talking about, let me pick up a different thing here, that if I'm talking about sodium chloride, you know that this right here is the cation, right? And this right here is the anion. And what do we know about the cation? It's a plus. What do we know about the anion? It's a minus. So the first part's a cation because it's positive. Second part's the anion because it's negative. And our signs of the electrodes work exactly the same way, which means that the anode here is negative, and that's where the aluminum is. Okay, so we know that the cathode then is the nickel, and that's the positive part. So anode negative, cathode positive. Okay? So just like when we name the different parts of the compound, we can trust that name when we talk about the charges then associated with the electrodes on a voltaic cell. So here's the next part. Do electrons flow from the aluminum electrode to the nickel electrode or vice versa? Well, here's the way it works. If we have one of these, let's say that's aluminum. I guess I should do, let me try this again, see if I can make this a little bit easier to understand. Here's aluminum because it's green, and that means it's the anode, which means it's the oxidation. Here is the nickel, and it's red because it's reduction, which means it's the cathode, which means it's the positive part. So as it turns out, electrons flow from the negative to the positive. Okay, negative to positive, which means they go from the aluminum, which is negative, to the nickel, which is positive. So the nickel electrode is positive, and the electrons flow over there. There's actually, so this is not completely correct because there must be some kind of permeable barrier that allows ions to go through it. So if the electrons are going in one direction, that means that the ions, the plus ions, are going in the opposite direction. Okay. So which direction do the cations and anions migrate through the solutions? Assume Al is not coated with its oxide. That's important because aluminum oxide is an excellent protection. So here's how this works. So in this case here, the electrons are moving through a wire from the aluminum electrode to the nickel electrode. So the cations are then migrating towards, let me see, should I use? So that means that cations are moving, the pluses are moving towards here, and the minuses, the anions, then are moving towards here. So which direction do the cations and anions migrate through the solutions? So that means that the electrons are gathering here, and they are moving through the wire, while the minuses are moving almost like to replace them, but I'm sure that's not exactly. But that's how I think of it, though. The electrons from the solution are moving to the electrode to replace the electrons that are traveling from the aluminum. And here, the positive cations are traveling to the nickel because of the increase in electrons over on the nickel electrode. But that's how I think of it. So we'll have more to talk about with the voltaic cell. I just wanted to introduce it to you. Like the plus and the minuses is confusing for everybody. So next time we'll do, like for 20B problems, we'll do some more like this is for sure what's going on. All right. So, enjoy.